All right. Limor, sorry, do you mind sharing your screen with the slides?
Sure.
Excellent. Thank you very much. So, Pierre Limor is a PC, is a doctorate associate director of for the research and strategic initiatives at the Institution for Social and Policy Studies, ISPS, at Yale University. And she led the creation of a specialized research data archive, the ISPS Data Archive, right? Which is a digital repository for research produced by scholars affiliated with ISPS with a focus on experimental design and method. She also co-founded the Curation for Reproducibility Consortium of Social Sciences data archives at Yale, Cornell, and the University of North Carolina. And today she's going to be talking about the cost of reproducibility in the presentation that we have. So please, Limor, the floor is yours.
Thank you. Thank you so much. Thanks, everyone. I'm really happy to be here and talk with you guys, talk with this group and get your perspective. I wasn't sure how this is going to go and how much time I have. I did throw together some slides, so I'm going to try to keep it within the time frame, but I do want to go over a few things and then just kind of get your take on the topic. So when I talked to Daniel, he said, can you talk about reproducibility? And then it sort of morphed into a conversation on the cost of reproducibility. I want to actually turn that question on its head and talk about actually a little bit about the cost of not doing reproducible research. So as we go through some of these slides, I just want you to think about these questions and consider what is the cost of irreproducibility? What effect does that have on the scholarly record? Basically, can we afford not to have computationally reproducible research? And then I think another really key question is, can we even really achieve computational reproducibility in every circumstance, in every discipline? When would we be okay accepting less than perfect computational reproducibility? What does that even really mean? And sort of what are the margins that we're willing to accept when we think about that, or when we attempt to verify or reproduce? So those are the kinds of questions I'm interested in, and we can kind of revisit them maybe at the end. So I want to talk briefly about computational reproducibility, what I mean by that. What does it mean to be curating for reproducibility? That's kind of where that cost question might come in, and then talk a little bit about the Research Data Alliance work that we're doing in this area. So first of all, computational reproducibility. So this is from a diagram that was published a few years back about what makes papers reproducible, when can other scientists reproduce the work of their colleagues. And I just want to point out that kind of green arrow that talks about access. Oftentimes, when we think about can we reproduce a research project, there's a question of access. So that's sort of the first barrier. I think that we've made a lot of gains as a community to make sure that data and code are more available now, and that's less of an issue, but a lot of times it's still an issue. But once we have access to the materials, in this case, the question specifically is about code, the next kind of question we want to know is, did you get the same outcome when you ran the code, when you try to do the computation? And that's kind of the area that we are defining for ourselves. So specifically about computational reproducibility, by now it's pretty much accepted that the definition is that we're looking for using the same data, same code, getting the same results. So I'm putting up here the definition from the National Academies of Science, Engineering, and Medicine in the United States. Also, the Turing Way sort of landed on this definition, as well as the ACM and other organizations and people who are working in this area. So same data, same code, same results. Why do we want to have reproducible research? Again, from the Turing Way. Many reasons. What they highlight is the fact that by having something reproducible, Oftentimes that means it is well documented. We can track the project history. It allows us to collaborate and review more deeply, avoid misinformation. If there's any questions about how certain results were achieved or outputs were created, we can go back and look at that. It allows us to write a paper more efficiently, not to mention going back to the work, writing another paper with a different set of data, and doing that more efficiently, to get credit fairly for the work that we're doing, and to ensure continuity so that people are not, they can build on what's been done, and we can continue to progress and not do a lot of duplicate efforts. So a little bit about where I'm positioned and kind of the work that we do. So the Yale Institution for Social and Policy Studies is a research center at Yale for the social sciences. I should pause for a minute because I kind of ran through the intro, but and just let you know that I was trained as a social scientist, so I come to this from the researcher perspective. I sort of found myself in doing this work almost accidentally. And so my point of view is not that of a software engineer or a librarian or anything more technical. And I really do keep that researcher focus in mind. So the ISPS, as we call our institution here at Yale, funds and supports all kinds of research that we think is important and has policy implications. And since 2011, we created what we're calling the ISPS Data Archive, which is opening up the public access to all of the underlying materials that form the basis for the research that is being done here. A lot of it is experimental research, and what we mean by that is randomized controlled trials in the field, mostly in political science, but not only, also economics, as well as more observational research in the social sciences. So we wanted to open up not just the articles and have a database of all the articles that are being done, but also provide the scientific community with the data and all the software and the code that went into producing the results. So when we created the ISPS Data Archive, we realized that we really wanted to make sure that if other people attempt to use these materials, they can actually use these materials. So we realized that that is a curation function, by which I mean, the function of verifying and examining these materials that we are putting in our repository and then making available, and going through some process of review of these materials to make sure that they are up to standards. And I'll talk a little bit about the standards in a little bit. But when we are talking about being first reusers, we're talking about, if you look on the right side of the panel in the white box, that is just a table from a publication. It's already been published. And there's a bunch of numbers there that are meaningful for people who are in this field, who want to know, the effect in this case of candidate support on interest in letters to the editor. Okay, so we have a set of numbers. We want to see, do the data, again, going with that definition of computational reproducibility. If I have the data and I have the code, do I get the same results? And so I'm looking on the left panel at the output that I believe in this case was produced in Stata, statistical software, I'm sure you all know. And so can I see those same numbers? This is a long time ago when we sort of started looking at these things. Now, we have statistical software that will actually produce directly the table as it will be used in the manuscript, and we don't have to go through and dig these numbers. There's other programs and ways of doing it more efficiently. But starting out, this is what we were looking at. We were literally combing through the output and making sure we can trace the number to an outcome. And so maybe it seems initially trivial. And even though we have these advances now of programs and other means of producing, writing into the directly into the results, it's not always easy to achieve what should be a minimal standard, right? Everything runs through a computer, and so if we just run it again through the computer, we should be getting the same results, but it's not always that way. So when you're using other people's data in code, a lot of times what happens is that you're running into all sorts of questions, and what we're trying to do is create a scholarly record that does not depend on the original author to be there to explain or to extend or to further our understanding, but that the material can stand on its own, be usable for the long term by anyone. So that is sort of the ideal. So if I don't know how a variable was constructed, I don't understand it, or I'm not sure where to start with the program files, or I don't know what the variable means, or I'm having just trouble running the code. I'm running into all sorts of issues. It's going to make it very difficult for me to understand the research and then to reproduce the research, and to make the research really usable. So with this group, I want to focus a little more on code. I want to say a word about that. I'm using the word kind of loosely, and I know people have different opinions on what, on definitions, but what I mostly refer to is scripts that researchers write to clean and analyze data. So this is research that's typically data first, right? And then there's an analysis of the data. Sometimes, so in any case, sometimes software is, and the software that is used, sometimes it's open source software like R, sometimes it's commercial software like Stata, but most of the time I'm not talking about researchers who are developing software or creating new software, although we do see that a little bit. So I'm talking about sort of scripts using available software. So we run into these sort of problems with code a lot of the times, that there are bugs, there's errors. Most of them are unintended. These are not, we're not doing these checks and finding anything untoward or, any kind of problems like that, but we're finding that the code doesn't run smoothly, and this creates friction. Okay, so it's kind of curious because in industries that rely on coding, everybody does a code review. Code review is actually a term of art in software development, and there are very good procedures for doing that. We don't really see that so much in the academy. A lot of the researchers, they're experts in their subject matter, and they want to do their work on that. And some of them are, more or less proficient with programming languages and software packages, and they'll use it as they can. But the kind of the habit, the practice of having someone else look at my code and rerun it is not always there. So when we, again, going back to our work at ISPS, when we said we're going to look at everything, make sure it's up to standards, the three sort of panels on the left, file review, documentation review, and data review, I would say fall within the realm of traditional data archives who accept data. So this could be, you could think of it as government data, statistics, administrative data, big repositories like in the United States, ICPSR, that have like national election data. And they have processes where they look at the files, they make sure the files are, they do some work on the bits, making sure that everything works. And then they look at documentation, making sure that things are documented, there's good metadata. And then they might look at the data themselves and say, make sure that there's no, for example, sensitive data. These are normal practices for good, kind of the gold standard. What we're adding to the mix is this code review, and the idea of let's also look at the data in the context of a particular result that's being reported, can we take that data, do all this work that other archives are doing, and then also run the code against the data to check for the results? So basically, we curate what we're thinking of as a reproducible file bundle. It's not just data, not just the code, it's the whole thing together, something that produces a result. We do this because we want to assess that we can achieve computational reproducibility, and then we also want to ensure that we are meeting all these other standards. So we're kind of doing it for both of these two reasons. We also try to do this before something is published. So there is, I think, still a conversation in some quarters of the academy about sort of post-publication peer review. So in other words, someone publishes a study, they make the data and the code available, then the community will decide if it's worthy, is this an important enough piece of research that I want to try and replicate or reproduce, and then I'll go in, and then ideally maybe there will be a place where I can report my findings and that sort of thing. I think that that's very important and necessary, and honestly, really, it's basically the scientific activity, right? That's what science is. So we certainly encourage that. We think that that should happen, but the way we're thinking about it is one step back. We're putting the data and the code in these repositories. We don't want to put stuff there that doesn't work, or that's uninterpretable, or that people just can't make sense of. So even before sort of the community does what the community does, we think that we need to have a step back and trying to work on these materials before they're made public. So we have a software tool that we use. We're going to try to, we've been using it for several years now, but we're trying to think of ways to improve it and also make it more widely accessible to others so they can use it as well. We are, now that Yale has its own instance of Yale Dataverse, we are going to try to connect YARD, our tool, to Dataverse, and the hope is that then other people who use Dataverse might be able to do that. But the idea is that there's this tool that kind of is a screening, or you can think of it as like a filter of some sort, a review step, basically, okay, where someone can deposit their materials, someone can then review and enhance the materials in any way, and someone can check off and certify that it was reproduced, and then only then it goes into the data repository and become more widely available. At the end, one thing I just wanted to show you the kind of issues that we come across when we do our code review. We have, I mentioned the 3 or the 4 sort of steps or parts that we have for our review. So this gives you more specifics. We look at questions surrounding files, questions surrounding documentation and data, and then the code. And we really take a deep look at everything here and make recommendations for our authors. So, all right, so that's kind of what we do. I have a group of slides, a small number of slides on the RDA work. I'll try to go through that quickly just to make sure I have time for questions. So through this work that I've been doing at ISPS, I got involved with a group of other institutions who are doing similar work. Specifically at the time, it was Cornell University and the University of North Carolina, Chapel Hill. And through RDA, we had an opportunity to really create a forum and a specific working group to talk about how do you do this work, what kind of recommendations we can give. And so I encourage you later to maybe take a look at these sort of high-level recommendations that we're making. Again, this was tailored to the social sciences. The idea is it might be a little bit different for different disciplines, and we encourage different disciplines to adopt these principles and to make it their own. So that was period of time that we worked at RDA on something that was called the Cure Fair Working Group. That is now completed its work, so the group is not active. But once that group sort of finished its work, we were thinking to ourselves at RDA, the Research Data Alliance, what else can we do around reproducibility? So there was an initial reproducibility interest group that was established back in 2014. Previous chairs were Bernard Schutz and Victoria Stodden, and it did some work. It then went into some hiatus, and so we came together, a group of us, and decided that we can talk to the community, the RDA community, and then see if there's interest, gauge the interest in this, and then based on that, make some recommendations and reinstate the group. And we were recognized and endorsed and reinstated in July of 2023. Current co-chairs include Claire Austin from Canada, Lauren Codwalder from PLOS, Mandy Gooch from UNC, and myself. What the group is trying to do is really advance this idea of reproducibility in research. And again, taking that approach that we're focused on research that's based on or produces data sets and requires code. So trying to kind of define the scope of the work a little bit. One of our main goals is really to be a bridge between RDA and a lot of efforts outside and out in the world, all sorts of organizations. Some really directly try to address issues around reproducibility, and some have work that touches on aspects of reproducibility that we're all trying to sort of pull in to be able to inform RDA about this other work and vice versa, and to create a community around this. And we're very much encouraging the creation of working groups under the interest group to take on specific topics of interest and to push forward a specific initiative, or if there's an idea for a deliverable or something like that. So we, like I said, got reinstated in 2023. We first had this birds of feather. What's next? After that, we made the pitch to update our charter. And after being recognized, we had, and these are all hyperlinked, so you'll be able, if you want, to go and see the notes. We re-established the reproducibility group. Last May, we skipped the 22nd plenary and held an asynchronous conversation where we invited a lot of groups to share with us in response to 4 questions. What do they do in terms of reproducibility? What's their vision for reproducibility? What some challenges are, and what would they like RDA to do? And so at the next meeting, and actually that's a typo, it's November 2024, we will present that work and engage the community with a mapping exercise so that we can start to understand the different players in this area and where they work, what they're working on, and just have a better understanding of that. So that's information about that specific session that we're having in November, and the agenda, and everyone is welcome to register and join. This is a hybrid conference, so if you can't make it to the Costa Rica, you could join in remotely, and I think that means the registration is lower. But regardless, you can become a member of the interest group if you want, and that doesn't cost anything and is open to anyone. I think you just have to become a member of RDA and then opt in to join the group, but that's free to anyone, and then you'll at least be notified and have access to some of the materials that come out, and to track kind of what we're doing. Okay, so I'll raise these questions again that that are interesting to me, and I would love to hear your thoughts on. But again, I'm open to anything you want to talk about or ask me. The cost of e-reproducibility and kind of the boundaries around computational reproducibility. When do we want to have perfect reproducibility? When does it make sense not to have perfect reproducibility? And what does that mean? So with that, I'll end. And thank you so much for your attention. I'll stop sharing my slides too.
Thank you, Limor. So I have many questions, but I would like to please, let the others go ahead first. So, Kai, please go ahead. And
Yeah.
by the way, we will have to limit a little bit the number of questions that we can do. So let's do a 10-minute discussion, right? And then we have to go back to the original agenda. Otherwise, we won't have time to cover everything that we have to cover today. But please go ahead, Kai.
Yeah, thanks a lot. Very impressive presentation, very impressive work that you're doing. Coming to the costs, I'm really curious about how much time does it take you to actually do one of those reviews, and how many papers do you review in that case?
That's a great question. We are in a privileged position that we don't have a very strong conditions that force us to do certain reviews in a certain amount of time. So we have the privilege of being more laid back about it. Okay, I'll start there. Some other organizations that are doing this, for example, the American Economics Review, or the American Economics Association, which has a number of journals, including the American Economics Review. They have a data editor who runs a team of people who do this. That's their job. And an article will not be published until it was reproduced. So they're under much more pressure than I am. Okay, so I'll just start with that. I can't really give you a number because the range is so large. I would say that it could range from, that most of the cases that we see might range from 2 hours of the full review to maybe 8 hours. There are some cases that are less, and there are some cases that are more. It really depends so much on the kinds of materials that we get. And I can say that over time, we see improvement in the materials. We see people who are commenting their code. We see people who are giving us one program file that runs everything. You know, that it's just organized in a better way and documented in a better way. We talk to our researchers a lot about, make sure that you, before you give it to us, have someone else who's not connected to this project try this on their computer. You know, so we do see improvements, but the time commitment is not insignificant because we do a lot of this manually.
Well, very good. I mean, it's not so much. An internal review in our community takes months until years.
Wow.
So,
okay.
Yeah.
Peter, please go ahead.
Hi, thank you. And great talk, by the way. So my question is there a consensus for like where the threshold is between computational reproducibility as like byte for byte identical versus this is the same results, it's just different floating point precision due to different CPU architectures, different GPU architectures, or things of that nature?
I think that is evolving, that the sense of exactly, I don't think there's a consensus yet. And I do think that it will kind of change depending on the discipline and depending too on the research, right? So for example, if you look at a typical article, empirical research in political science, they did a survey, they analyzed the survey, they present the results. It seems like you should get the same result. If the data are static and the code is the code and you run it, you know, there's no reason. We sometimes don't get the exact same results for things like rounding error, differences between programs. So we'll allow that. We want to note that, but we'll allow that. So if we can't fix it, we might want to explain it. But I think that in other disciplines, it could be different. You know, some computation is not deterministic by nature, so that's kind of a problem. Like, how do you wrap your head around that one? What would reproducible mean? You know, just being able to, yeah. So you wanna. So I think that having a sense of what would be acceptable outcomes and what would be acceptable margins around the outcomes is work that each community is going to have to do. But I think that it starts with being able to just run the code. You know, I can't even tell you, like, and you know, as much as we were all excited when R kind of took off, at least in the social sciences, because it's open science and there's a whole community that supports it. We do see code breaking down more than in some commercial products that are a little bit more stable. But the downside is they're, you know, licensed. Not everybody has them. There's questions of reproducibility there too. If that company goes away, so.
Yeah. You have to be able to run it to find out enough to even get to the question of, are the results the same or not?
Yeah, I think that in the kind of in the realm of if you can't perfectly run it, or if you can't run it at all, would it be acceptable to add the output, the literal computational output, as evidence of some sort that it was run at one point, this is what was produced, and that will have to do. At least for future generations, they'll be able to kind of like understand what was happening and be able to see that it did work. So it depends too on what the purpose of it is. Yeah.
I think this is also quite interesting because now, at least in research more closely to my area, I see a lot of machine learning being done with LLMs, right? And there, the response sometimes is not deterministic. It is true that you will have to agree on setting the temperature with the parameters to give to the LLM to try to reproduce, but reproducibility is never ensured. So it's interesting that you mentioned what is it exactly, the reusability and reproducibility versus replicating exactly the same results, no? I usually tend to think that it's better, I mean, that if I can reuse someone else's approach, even if it's not exactly the same, as long as the results are consistent, it should be good enough. But what you mentioned, the publishing the provenance trace of previous computation is what we have also been recommending people to do, because it gives you also a set of like milestones that, okay, well, up until this point, I know that I should have gotten to this, and then it was that, and then it was that. But I see Alan with his hand raised, so I don't want to cut in line. Sorry, Alan.
No problem, Daniel. I just wanted to talk about this, kind of revisit this idea of the costs of maintaining these artifacts into perpetuity. Have you run into any issues around that? Because you know, just because you could run it at the time that it was curated does not mean that it will continue to run in 3 to 5 or years.
Right. Completely, absolutely agree with that. And again, taking our cues from sort of the library and archive world, they have practices where they go back to the artifacts that they have in their possession, and they check the bits, and they check for loss, and they do all sorts of other things. And so we wanted to piggyback on that idea and say that exactly what you're saying, verification at T1 is only good for T1. If we wanted to go back in 3 years, that's really the recommendation, is to go back and try to run it again after a while, because you have packages that have been decommissioned. We ran into that, that kind of prompted a whole study that we did. As a result of doing that study and finding some problems, things that were verified as computationally reproducible at one point were not a few years later. And so the idea is to have more of a active maintenance. And that's actually the term that we sort of advocated for. We should have active maintenance so that we can come back. And I'm hoping one day we'll be able to do this automatically, because you're right, we're taking in so much materials right now and promising that we're going to keep them forever, or, you know, for the long term, being kind of undefined what that means.
Yeah, 5 years or forever, whichever
Yeah,
comes first.
exactly. Exactly. So, right, and the comment is, that's right, it's going to fail at some point. So, what is the conversation we want to have about what do we expect will work? Why do we expect that it will work? Like, is it important that this will work? Yeah, and containers are, you know, digital archivists really don't love that idea, because their whole, you know, kind of thought is, we need to make the files as flat as possible, you know, unrestricted, because that's easier to take care of them. And now we're going to wrap them in this other apparatus that now we're dependent on that for something to run. So I don't know that there's a great answer.
Thank you. Yeah, I mean, we've been thinking about this for some time too, and there's a lot of costs associated with maintaining things into perpetuity, and so so that initial question that you raised is really top of mind for, I think, a lot of us in this space.
Yeah, I'll just mention, I didn't mention that there's also an ACM interest group on reproducibility. So they think about those issues more from a technical side, and that might be also another group, if you're not affiliated with it, that might be interesting.
Right, right. Kind of where we've lined up is that if there's enough sustained community interest in maintaining the software, and so that's why we've been trying to build out workflows that lead to community support into the future. Like, you just build a transparent research object, you have fair metadata, you try to make sure it was frictionlessly reusable at one point, and then hope that if it's useful and continues to be relevant, then all the pieces are there for the community to maintain it down the line, and on infrastructure, public infrastructure like GitHub or GitLab or something.
Yeah, absolutely. And you said frictionless, and that just reminded me that again, that's something, it seems like what we want. And in most cases, I think it's what we want, but I started thinking that there are situations where friction is actually not necessarily a bad thing, like in an educational setting, for example, where you want to teach students, like, why doesn't this work? And, you know, what can, you know, having that be kind of an exercise, or other contexts that you might think about where not making something so easily and perfectly available has a reason. But I think those need to be kind of spelled out so that we understand better what, you know, yeah.
All right, so I think we have to move on. I really like also the comment from Peter that even if you don't have the code, or at least the executable, having the algorithm implementation and documentation that also explains how it works, sometimes may be enough to reproduce it in newer settings or newer environments. So thank you.
That was Alice's
Limor.
idea, by the way. I was just pitching in to agree with her.
Thank you. Okay, and
A great
is it possible for us to get a copy of your slides? Your slides are excellent. The presentation was excellent, and your slides are excellent too.
Thank you. Yes, absolutely. I'll send it to Daniel. Yeah.
Great, thank you.
Yeah.
Thank you. So I'm gonna stop the recording. Thank you again. Well, I think we can